Is 3/8 coming to Earth? That's the question. Keeping astronomers awake at night after what just happened at Mars completely shattered every prediction we had about this interstellar visitor. Everyone assumed Atlas would pass by Mars and continue its journey through the solar system. Instead, the mysterious object performed maneuvers that should be physically impossible, stopping dead in its tracks and deliberately parking itself in orbit around the red planet. And what it did next has transformed this from a fascinating astronomical discovery into a potential threat scenario. Scientists tracked Atlas approaching Mars at 130,000 miles per hour, fast enough to circle Earth 5 times in a single minute. The flyby was supposed to be routine. Quick observations, some data collection, then Atlas would speed away into the outer solar system. But that's not what happened. Atlas slammed on the brakes. In less than 6 hours, it decelerated from interstellar velocity to a complete stop relative to Mars, then inserted itself into a perfect circular orbit. The energy required for that maneuver equals 3 years of output from every nuclear reactor on Earth combined. Natural objects don't do this. Comets can't stop themselves mid-flight. Asteroids don't execute precision orbital insertions around planets they've never visited before. What we're witnessing isn't astronomy. It's technology. Advanced technology that makes our most sophisticated spacecraft look like Stone Age tools. And here's what has NASA frantically recalculating trajectories. After completing its mission at Mars, Atlas appears to be preparing for departure. Early projections suggest the next stop could be Earth. We might have less than 6 weeks before this object, whatever it really is, arrives in our neighborhood. The question isn't just what happened at Mars anymore. It's what will happen here when Atlas comes knocking. The Mars Reconnaissance Orbiter captured the entire event in stunning detail, and the data has left astrophysicists struggling to explain what they're seeing. Atlas approached Mars at its expected velocity of 130,000 miles per hour. Then, at a distance of approximately 50,000 miles from the planet, something activated. The object began emitting an intense blue-white glow from what appeared to be multiple points along its structure. Not the diffused glow of reflected sunlight, but focused emissions that looked disturbingly like engine burns. A propulsion engineer analyzing the data described the impossibility. The deceleration profile shows constant thrust over a 6-hour period, bleeding velocity at a rate that would require exhaust velocities approaching 10% the speed of light. We don't have propulsion technology that comes remotely close to this. Neither does any nation on Earth. This is orders of magnitude beyond our most advanced theoretical concepts. The energy calculations are staggering. To slow an 800 m object from interstellar velocity to orbital velocity requires approximately 10 to the 20 power joules of energy. For comparison, the atomic bomb dropped on Hiroshima released about 10 to the 14th power joules. Atlas just demonstrated the equivalent of 1 million nuclear weapons worth of controlled thrust. But it's not just the energy that's impossible, it's the efficiency. Conventional rocket engines waste enormous amounts of energy as heat. The infrared signatures from Atlas during deceleration showed temperatures barely above ambient space levels. Whatever propulsion system it's using operates with near-perfect efficiency, converting almost all input energy directly into thrust. Multiple space agencies tracked the maneuver using different instruments and all confirmed the same impossible physics. The European Space Agency's Mars Express captured spectroscopic data showing exotic particle emissions. The same strange quarks and muon signatures detected during unexplained events throughout Atlas's journey. A particle physicist reviewing the data made a disturbing observation. These particle signatures match theoretical predictions for antimatter propulsion systems. If Atlas is using matter-antimatter annihilation for thrust, it's carrying fuel that could theoretically level a continent if it detonated. And it just parked that weapon in orbit around Mars. The deceleration burn wasn't uniform either. Atlas executed a series of precisely timed thrust adjustments compensating for Mars's gravity, solar radiation pressure, and orbital mechanics in real time. The computational requirements for that kind of precision are mind-boggling. It's like threading a needle while riding a motorcycle at highway speeds. As Atlas settled into orbit around Mars, something even stranger began. The objects started scanning the planet systematically, methodically, and with technology that makes our best satellites look primitive. The Mars Reconnaissance Orbiter detected powerful electromagnetic pulses sweeping across the Martian surface in geometric patterns. Each pulse lasted approximately 3.7 seconds and covered a strip of terrain 200 kilometers wide. Over the course of 12 hours, ATLAS completed a full mapping survey of the entire planet. A planetary geologist analyzing the scan patterns described what they're seeing. This is high-resolution ground-penetrating radar, but operating at power levels and frequencies we've never achieved. The pulses are penetrating kilometers into the Martian crust, mapping subsurface structures, water deposits, and geological formations with incredible precision. Whoever built this wanted a complete picture of what's beneath Mars's surface. But the scanning wasn't random reconnaissance. ATLAS focused particular attention on specific regions, areas that happen to coincide with locations that have puzzled scientists for decades. The Cydonia region, famous for the face on Mars formation that turned out to be a natural mesa, received intense scrutiny. So did Val Marinis, the massive canyon system that dwarfs Earth's Grand Canyon. And most intriguingly, areas where ground-penetrating radar from NASA's SHA instrument had detected what might be ancient lake beds or subsurface ice deposits. A Mars exploration specialist noted the implications. It's almost like ATLAS knows exactly where to look. These aren't random survey patterns. They're targeted investigations of the most geologically and historically significant features on Mars. Either they've studied our research data or they know something about Mars's past that we don't. The Perseverance and Curiosity rovers both detected unusual phenomena during ATLAS's overhead passes. Electromagnetic interference disrupted communications for brief periods. Instrument readings showed anomalous magnetic field fluctuations, and both rovers' cameras captured strange atmospheric disturbances, shimmering effects in the thin Martian air that suggested some kind of energy beam passing through. Most disturbing of all, ATLAS appeared particularly interested in the regions where we've sent our most advanced equipment. The Jezero crater, where Perseverance is searching for signs of ancient microbial life, received 3 separate detailed scans. It's as if ATLAS was checking to see what we found or making sure we haven't discovered something they don't want us to know about. The orbital insertion maneuver itself raised questions. ATLAS positioned itself at exactly 12,000 miles altitude, high enough to avoid atmospheric drag, but low enough for detailed observation. That specific altitude isn't random. It's the optimal position for maximum surface coverage while maintaining stable orbit. It's exactly where you'd position a reconnaissance satellite if you wanted the best possible intelligence gathering capability. Then ATLAS did something that has turned scientific curiosity into genuine alarm. It began releasing objects toward the Martian surface. The Mars Reconnaissance Orbiter captured the first deployment, a small object roughly 10 meters across separating from ATLAS and descending toward Mars on a controlled trajectory. Then another and another. Over a 48-hour period, ATLAS released at least 23 distinct objects, each following precisely calculated descent paths toward specific locations on the surface. A planetary defense specialist described the nightmare scenario. We're watching what looks like a military deployment. These aren't random debris or jettisoned fuel tanks. Each object follows a ballistic trajectory designed to reach a specific ground target. This is the pattern you'd see during an orbital bombardment or a landing operation. Tracking data shows the objects decelerated during descent. Another impossibility for inert debris. They used some form of atmospheric braking combined with active thrust control to slow their approach, eventually impacting or landing at velocities gentle enough to keep them intact. The impact sites are spread across Mars, but show a definite pattern. Several landed near the polar ice caps. Others touched down in regions with suspected subsurface water deposits. 3 landed within 50 kilometers of Perseverance's current location. 1 appeared to target the Valles Marineris Canyon system directly. NASA's satellite network attempted to track the objects after landing. But here's where things get truly unsettling. The objects vanished from sensors shortly after touching down. Not destroyed, vanished. Thermal signatures disappeared. Radar returns ceased. It's as if they buried themselves or activated some form of stealth technology. A remote sensing specialist explained the technical impossibility. Our Mars orbiters use multiple detection methods: infrared, visible light, radar, spectrographic analysis. For an object to disappear from all of them simultaneously means it's either been destroyed so completely that no trace remains, or it's using technology to actively defeat our sensors. Given the controlled descent we observed, destruction seems unlikely. One object landed within visual range of the Curiosity rover. Mission controllers immediately redirected the rover toward the landing site, hoping to get imagery of whatever Atlas deployed. The rover covered 3 kilometers over 2 days. But when it reached the coordinates where the object should have been, there was nothing. No crater, no debris, no disturbance of the Martian soil. Either NASA's trajectory calculations were wrong, unlikely given the precision of modern tracking, or the object moved after landing. Both options are deeply troubling. The thing nobody tells you is that Mars now hosts technology we didn't put there and can't see. At least 23 objects of unknown purpose and capability are now deployed across the Martian surface, possibly transmitting data back to Atlas, possibly performing functions we can't even imagine. While Atlas maintained its orbit around Mars, NASA made a decision that has sparked intense debate. They attempted direct communication. The Deep Space Network, NASA's array of massive radio telescopes used for communicating with distant spacecraft, was redirected to transmit toward Atlas. The message was simple. Mathematical sequences, prime numbers, and basic geometric proofs designed to demonstrate intelligence without requiring shared language. A SETI researcher involved in crafting the message described the approach. We used the same principles developed for messages to extraterrestrial intelligence, but this time we knew something was listening. The question wasn't whether anyone would receive it. It was whether they'd choose to respond. For 36 hours, there was no response. NASA repeated the transmission at different frequencies and power levels. Still nothing. Some scientists argued that Atlas either couldn't detect the signals, wasn't interested in communication, or was deliberately ignoring Earth's attempts to make contact. Then everything changed. Atlas suddenly altered its electromagnetic emissions. Instead of the mathematical constants and geometrical patterns it had been broadcasting since entering the solar system, the signals shifted to something new. They began incorporating elements from NASA's transmission, not echoing them exactly, completing them, expanding them, demonstrating mathematical concepts more advanced than the ones Earth had sent. A cryptographer analyzing the response described it as both encouraging and terrifying. They're not just acknowledging our message, they're testing us. Each response includes mathematical problems progressively more complex than what we sent. It's like they're administering an intelligence test, seeing how sophisticated our understanding really is. But the communication wasn't limited to mathematics. Some of the returned signals appeared to contain encoded imagery, complex patterns that when processed through various decoding algorithms might represent visual information. One research team successfully decoded what appeared to be a three-dimensional map, not of our solar system, of another star system entirely, possibly their point of origin. The map showed orbital positions, planetary masses, and what might be structures in orbit around one of the planets. If authentic, this would represent the first direct communication of extraterrestrial geographic information.